In this video we are going to discuss three-dimensional coordinate systems and recall how they can be used to turn geometric objects into equations or inequalities. So let me just remind you that a 3D coordinate system looks like this. This is a Cartesian coordinate system with three pairwise perpendicular lines all intersecting in one point, which is called the origin, and then the coordinate axes are labeled x, y, and z according to the right hand rule. So when you curl your fingers around of your right hand around the z axis so that they touch the x and then the y axis, your thumb should be pointing in the positive z direction. Once you choose a unit of distance, you are good to go to coordinate the entire space, meaning that if you have a point, any point in space, let's say this one floating in space, let's call this P, this point P, then you can go ahead and assign a ordered triple of real numbers as its coordinates. So you can basically say that this point has its x and y coordinates like so. So this would be the x coordinate, let's call it A. This would be the y coordinate, let's call it B, and the z coordinate, let's call that C. So A, B, C are the x, y, and z coordinates of our point P. So this way we just turned a geometric object into a triple of real numbers. And now I can ask you, my first question is, what kind of geometric object in 3D space is represented by the equation y equals 5? So pause the video and select your answer below. Okay, I hope you paused the video. So this equation gives us a plane, that is parallel to the xz plane, so that wall, and intersects the y-axis at y equals 5. Okay, so this condition that y should be equal to 5 leaves us with all the points whose coordinates are as follows. The x and z coordinates can be anything, and the y coordinate has to be equal to 5. So x and z can take values from the set of real numbers, any values from the set of real numbers. So this is a plane. Let me try to sketch that. So let's say here is that plane, and the y-axis pierces through the plane at 5. Okay, so this would be the answer to this question. Okay, let me give you another question. So we are now looking for a region in 3D space that's given by two inequalities. So the first inequality is x squared plus y squared is less than 1, and the second inequality is z is between 2 and 4. So what geometric object or region in 3D space is encoded in these inequalities? Pause the video and select your answer below. Okay, I hope you paused it. So these two inequalities will give us a solid cylinder, and to see why that is, first we look at the first inequalities. So remember, so let me just say is a solid cylinder. And the reason is that the first inequality is, if you look at the xy plane, remember in plane geometry, when you had x squared plus y squared equals 1, that gave you a unit circle centered at the origin. So that's a unit circle. And since we look at the points where x squared plus y squared is less than 1, we are actually looking at points in the interior of this unit circle called the unit disk. So we have this unit disk, and then its height, the z coordinate, should be between 2 and 4. So imagine lifting this disk and sweeping through the region where the z value is between 2 and 4. Let me try to draw that as well. So here we have the axes 2 and 4 along the z-axis, and then we have this unit disk at these heights, but all disks between those heights are also valid, satisfy these inequalities. So that's why we have this solid cylinder. Okay, so that's the second question I had. Before I ask the third question, let me just say that how we compute distances. So you might be interested in the distance of this point and the between this point and the origin. So how far away this point is from the origin. And to answer that question, we need the Pythagorean theorem applied twice. So this line segment is actually the hypotenuse of a right triangle that I have right here. It doesn't seem like a right triangle because we look at it at a skew angle, but this right triangle has as its length, the length of its legs are c and this distance, and to compute that distance we need to employ another right triangle that we have right here, of which that is the hypotenuse and its legs are a and b. In fact, if we look at distances, really these should be the absolute values of the coordinates, because they could be negative numbers, these coordinates. Okay, so now if we look at that hypotenuse first, according to Pythagoras, it's a squared plus b squared equals this length squared. So if I want to get that length, I have to take the square root of a squared plus b squared. And now applying Pythagoras' theorem again to get the length of that hypotenuse, I get well, this leg squared, so that's a squared plus b squared, plus the other leg squared, so that's going to give me c squared, all under the square root. So this is how we can compute the distance of a point from the origin. It's just the square root of the squared sum of its coordinates. Okay, the square root of a squared plus b squared plus c squared. So, and similarly, the distance between 2 points can be calculated in a very similar manner. Between 2 points, let's call it P1 with coordinates x1, y1 and z1, and P2 with coordinates x2, y2 and z2 is the following. It's denoted by these absolute values. So the distance between P1 and P2 is the square root of the squared sum of the differences between corresponding coordinates. So we take the square of x2 minus x1, the square of y2 minus y1, and the square of z2 minus z1. We add these squares up and take the square root. So that's the length, that's the distance between these 2 points. Okay, and so for my third question, let me ask you for the radius of a sphere whose center has coordinates 3, -1 and 6, and the sphere passes through the point with coordinates 5, 2 and 3. So what's the radius of such a sphere? Pause the video and input your answer below. Okay, I hope you paused it. So since the sphere is centered at this point and passes through that point, the radius is just the distance between those two points. So the radius is just the distance of C and P, and if you look at that formula, we have to take the square root of the squared sum of coordinate differences. So the first coordinate, there the difference is 2, so we have to square 2. Second coordinate, there the difference is 3, so we have to say, take 3 squared. And for the third coordinates, the difference is again 3, so we have to square that. So this way we get 4 plus 9 plus 9, so that's giving us root 22 for the radius. So that's our answer. Okay, I hope you enjoyed this video, and I'll see you in the next one.